Okay, this is map 10. Before we start to do the cross section, we need to interpret the map and decide what features we can see on there and determine the order in which we're going to construct our cross section. Looking at the map, we can see that there are various different features on here. We've got a sheet-like igneous body which is running in a roughly northeast southwest direction, which is this body E here. We've got an igneous pluton in the northern quadrant with its associated metamorphic aureole. We can also spot an unconformity in this top corner. The layers of rock directly above the unconformity are horizontal. So let's mark in the unconformity. And from the age relationships, we know that this dike is younger than the unconformity, but the pluton is older than it. If we look at the rest of the map, we can see that the sedimentary layers A, F, G, etc. have show evidence of folding. We can see this because A isn't repeated, F is on either side, and C is on either side of that. If we look at the dip direction and the dip amount, when you sketch the cross section, it's going to be exactly the angle which is on the map because the dip direction and the line of section are parallel to each other. So you're going to mark on the true dip amount. So what we're going to do now is mark on the APT of the fold, and it's going to have a northwest southeast trend. And because the beds are dipping away from the centre, it's an antiform in that orientation. One last structure to spot in the bottom right hand corner is that we've got a fault here, and it looks like it's got vertical displacement because the outcrop width for layer A is different on either side of the fold. The APT of the fold will continue across, and we can actually work out which side of the fault has moved down based on the relative outcrop width on either side of the fault. Because it's an antiform, it is always going to be narrower on the down-thrown side. So this side of the fault is the one that's gone down relative to this side here. All the information that I need is now being placed on my strip of paper so that I can do my cross section. Before I do that, I need to work out the order in which I'm going to do the cross section. So looking at the map, I know that the dike is the youngest feature, so I'm going to put this one in first. Then I'm going to put in the unconformity and the layer above the unconformity, and then I'm going to do the folded layers underneath. I don't need to worry about the pluton because it's not on our line of section. Okay, let's do this cross section. First thing I was going to do is look at the dike. Because it's a sheet-like body and it's straight on the map, this will suggest that it's vertical. So I'm going to mark the dike onto the cross section and draw again all the way through the present day land surface up there because I know it cuts across everything on the map. Next thing I'm going to do is mark on the unconformity. It looks like it's there. And if we go back to the map, we've got these equal-sided crosses that tells me that it's horizontal. We know the unconformity cuts across all the layers. So what I'm going to do is mark that on. Okay, notation on. And let's just label that up as being the unconformity. Next thing I'm going to do is mark on the folded layers. So I'm going to start on this side where I know I've got all the boundaries exposed at the surface. So this one is going that way at 30 degrees. So this boundary here. Going to extend it up to the unconformity because it was there but it's been eroded away. And going to put them in my notation straight away so I don't forget which layer it is. It's a limestone. And then looks like we've got a shale or some type. In the centre, I've got the white layers. I'm not going to mark on my fold axis until it's nearly, I've completed the rest of it. Fold changes direction there. Next rock type there. And it looks like it's limestone all the way underneath the unconformity on the map. One last thing we need to do is mark on the fold axis. Now, you've got to try and divide this up equally. Because the dips are unequal on either side, that would suggest that the fold axis is inclined. So I've got the unconformity, the fold with the inclined fold axis. Finished.